You've heard structural and fabricated steel used interchangeably. This common mistake can have massive consequences. The distinction is a legally mandated standard that separates a standing skyscraper from a catastrophic failure. At its heart, it's a difference between what a material is and how a material is processed for a specific job. One has a fixed chemical recipe for predictable strength. The other can be formed from countless steel types for any need. We will break down the key distinctions you must know, from composition and manufacturing to application, cost, and legal codes. Let's lock in the first principle. Structural steel is a noun, a specific, defined material engineered for load bearing. Fabricated steel is a verb, a custom process that can be applied to almost any grade of steel for a specific outcome. This leads to two different manufacturing worlds: standardized, regulated production for shapes like I-beams versus the custom, project-specific creation inherent to the fabrication process itself. This standardized composition gives structural steel a high strength-to-weight ratio, meaning taller buildings with less material. It's also exceptionally durable, resisting fire and pests, and can last for centuries with proper maintenance. And because components are made off-site, on-site assembly is incredibly fast, often beating concrete timelines by months. So why are the regulations for structural steel so strict? Because codes like AISC and Eurocodes aren't guidelines. They are legally binding requirements. BIM and CAD create a digital twin of the structure, ensuring every cut and connection point is precise. So if the material is standardized and the technology is precise, where can things still go wrong? The answer is in the fabrication process itself. Even a minor weld deviation, a bolt length miscalculation, or a misplaced hole can compromise load-bearing capacity. So who is responsible for catching these potential disasters? This is why the misconception of fabrication as just manual labor is so dangerous. It's a high-tech discipline where precision is paramount to safety and success. Even after perfect fabrication, the job isn't done. Protective coatings and regular inspections are vital to prevent corrosion and ensure the structure meets its intended lifespan. So where do we see structural steel? Think big: skyscrapers, massive bridges, and industrial warehouses where predictable, immense strength is non-negotiable. Fabricated steel is everywhere else: automotive chassis, aircraft components, and precise surgical tools. Here, the process is adapted to the specific needs of the object. A special category is architectural fabrication, ornamental facades and complex staircases. Here, aesthetics are as valued as strength, but it's still a fabrication process. Smart projects often use a hybrid approach, combining cost-effective structural steel for the main frame with custom fabricated steel for unique architectural features. Now that you see the difference in application, look around you. Can you spot which objects are products of structural integrity versus custom fabrication? Which is cheaper? It depends. Mass-produced structural steel suits large, simple projects, while fabricated steel's precision can save costs on custom jobs. Remember our question about who catches errors? That's the crucial role of the steel detailer. They are the final line of defense against costly mistakes. An error caught on their screen saves thousands in rework. Beyond cost and safety, there's the environmental angle. Steel is endlessly recyclable without losing quality, saving up to 75% of the energy needed for new production. The practice of off-site prefabrication also dramatically reduces on-site construction waste, making steel a key component of efficient, sustainable building methods. So here's the link. The what, structural steel's properties, makes bridges possible. The how, its fabrication, turns it into a car door. We saw how BIM and robotics ensure precision. That precision enables the rapid off-site assembly we mentioned, which in turn reduces on-site waste. Think about the strength-to-weight ratio. It means less material, lower transport costs, smaller foundations, and a more economical project from start to finish. Grasping these connections isn't academic. It is the key to making informed decisions that affect a project's budget, timeline, and ultimate safety. Structural steel versus fabricated steel isn't a competition, it's a spectrum. One is a regulated material for strength, the other a custom process for limitless applications. Knowing the difference is fundamental for any professional in this field. The professionals who master these distinctions are the ones who can innovate, optimize costs, and build the future with confidence and precision. If you found this breakdown valuable, share it with a colleague. And comment below with the most surprising distinction you learned today.